Identifying devices on a network. The first thing that I can see, I see that we have a website built in here to display these concepts that we'll go through. And let's see. To communicate and maintain order, devices must be both identifying and identifiable on a network. What use is it if you don't know whom you're talking to at the end of the day? Devices on a network are very similar to humans in the fact that we have two ways of being identified: by our name, by our fingerprints. Now, we can change our name through deed pool, but we can't, however, change our fingerprints. Every human has an individual set of fingerprints, which means that even if they change their name, there is still an identity behind it. Devices have the same thing. Two means of identification, with one being permeable. These are an IP address and a media access control, a MAC for short. Think of this as being similar to a serial number. IP address, which is changeable, and the MAC address. MAC address can be changed also, it's called spoofing, but you know, when you learn concepts, it's easier to learn the basics and then move forward to advanced topics. But the IP address is the one that is changed when we compare it to the example of above, like our name, and our fingerprints are the MAC address. When we talk how we identified a PC, how can we identify the device on a network? IP addresses, briefly, an IP address or internet protocol can be used as a way of identifying a host on a network for a period of time, where that IP address can then be associated with another device without the IP address changing. First, let's split up precisely what an IP address is in the diagram below. We have the 4 octets. An IP address is a set of numbers that are divided into 4 octets. The value of each octet will summarize to be the IP address of the device on the network. This number is calculated through a technique known as IP addressing and subnetting, but that is for another day. What's important to understand here is that IP addresses can change from device to device, but cannot be active simultaneously more than once within the same network. If IP addresses follow a set of standards known as protocols. These protocols are the backbone of networking and force many devices to communicate in the same language, which is something that we'll cover onto another time. However, we should recall that devices can be on both a private and a public network. Depending on where they are, will determine what type of IP address they have, public or private. A public address is used to identify the device on the internet, whereas a private address is used to identify device among other devices. Take the table and the screenshot below as an example. Here we have 2 devices on a private network. We see these the same, so we have 2 devices that is on both private and public networks with the associated IPs. The first example we have right here, the IP and the MAC address. It's a wireless 5 gigs. Same in here. These two devices will be able to use their private IP addresses to communicate with each other, right? These two addresses to communicate between the two. And then, however, any data sent to the internet from either of these devices will be identified by the same public IP address. This one and this one. Public IP addresses are given by your internet service provider or ISP at a monthly fee, basically your bill. My public IP address is this. We can also see the internet service provider of this example, Secure Communications, TLD. As more and more devices become connected, it is becoming increasingly hard to get a public address that isn't already in use. For example, Cisco, an industry giant in the world of networking, estimated that there would be approximately 50 billion devices connected to the internet by the end of 2021. Enter IP addresses, versions. So far, we have only discussed one version of the Internet Protocol addressing scheme known as IPv4, which uses a numeric system of 2 to the power of 32. I think it's 2 to the power of 32. Yes. 2 raised to the 32 power, 32nd power, which is 4.29 billion IP addresses. IPv6 is a new iteration of the Internet Protocol addressing schemes to help tackle the issue. Although it is seemingly more daunting, it boasts a few benefits. Supports up to 2 to the power of 1828 of IP addresses. Oh my god. 340 trillion plus IP addresses, resolving the issue faced with IPv4. More efficient due to new methodologies. Okay, here we have the comparison of the two. And then MAC addresses. Devices on a network will all have a physical network interface, which is a microchip board found on the device's motherboard. This network interface is assigned a unique address at the factory it was built at, called the MAC, Media Access Control Address. The MAC address is a 12-character hexadecimal number, a base 16 number system used in computing to represent numbers, split into twos and separated by a colon. These columns are considered separators. For example, this one. The first 6 characters represent the company that made the network interface, and the last 6 represents 6 unique numbers. Okay, we have the same example over here. So it's Intel, the vendor of the, we can identify it by the first 6 numbers and the unique number. However, an interesting thing with MAC addresses is that they can be faked or spoofed in a process known as spoofing. This spoofing occurs when a network device pretends to identify as another using its MAC address. When this occurs, it can often break poorly implementation security designs that assume that devices talking on a network are trustworthy. Take the following scenario. A firewall is configured to allow any communication going to and from the MAC address of the administrator. If the device were to pretend or spoof this MAC address, the firewall would now think that it is receiving communication from the administrator when it isn't. Places such as cafes, coffee shops, and hotels alike often use MAC address controls when using their guest or public Wi-Fi. This configuration can offer better service. a faster connection for a price if you are willing to pay the fee per device. The interactive lab attached to this task has been made to replicate this scenario. The interactive lab simulated a hotel Wi-Fi network where you have to pay for the service. You'll note that the router is not allowing Bob's packets, which are blue, to the TryHackMe website and is placing them in the bin, but Alice's packages, which are green, are going through fine because she has paid for Wi-Fi. Try changing Bob's address with the same as Alice to see what happens. Deploy the interactive lab and proceed to answer following questions below. Okay, let's see. Alice is... Okay. Okay, let's change it. 00 12 32 2F 33 and 39. Request the website. And we can see that it's going. Okay, let's see. What does the term IP stand for? Internet Protocol. You can write it without it's not case sensitive, which is good. We can see that it's not case sensitive. Let me just write real quick here. 29. Yes, 14. What? Let me see. I can place here 14. What? Jesus Christ. 1, 4. Oh, okay. Okay. 29. 2 more days and it's a new year. What is each section of an IP address called? Octet. All right. How many sections in digits does an IP address have? 4. What does the term MAC stand for? Media Access Control. And we spoofed the MAC address of Bob. TryHackMe, you got on TryHackMe. Pretty cool, pretty cool, pretty cool.